tutorial on the June 2012 paper, and here's question 4. And it's a graph question, and we're asked on separate diagrams to sketch the curve with the equation, and here are the 3 equations we're asked to sketch. And we're given a graph with the equation y equals f of x, and we're given 2 points, and on each of the graphs we're asked to show where those 2 points would be. The first one is y equals modulus f of x, and what we know about a modulus function is that all of the negative y values will become positive values. So what we will have in effect is the same part on top coming down like so, and instead of going under the graph it will come back on top like so. So where are the 2 points going to be? Well, P is still in the same place because it hasn't moved, and we haven't done any sort of enlargement, and Q also is in the same point, it's there. So I'll just label those. That's P, and there's Q. And that's it for the first part. For the second part, we're asked y equals the f of x, but in this case f of modulus x. So the modulus sign is only around the x value. And what that means is that all y values which are negative disappear, and we have a reflection about the y-axis of all the positive values. So we're just taking this part of the curve and of the function and reflecting it in the y-axis, and that's what I've just drawn there. And obviously P disappears because there is no P. P is a negative value, and therefore it disappears. And we are left with Q. Now for the last one, it's enlarging both y and x values, or not necessarily enlarging the x, but it's being times by a certain number. And the way I look at these questions is the bit before the function is going to affect, or the bit outside the bracket is always going to affect the y values. And it's 2f of x, so if it's outside we do exactly what it says. So for all the y values we were given, we're going to times them by 2. That's how I like to think of it. The bit inside the bracket, we do the exact opposite. So instead of timesing by 3, we're going to divide by 3. So that's what we're going to have. So what does that mean in terms of how our graph looks? Well, it's going to look something like this. And of course, there's no modulus function on this graph, so we're still going to get negative values as well. But we need to indicate what the new coordinates of P and Q will be. And that's quite simple, really, isn't it? Because for Q, what we've got x equals 0 and y equals 5. Now if x equals 0, 0 divided by 3 is 0. So 0. But y times 5 times 2 is 10. So we're going to get 0, 10. For the p value, I'll just write it here. Well, minus 1.5 divided by 3 is minus 0.5. And 0 times 2 is 0, so we have minus 0.50. And there you have it. That's question 4. Join us again for question 5.